Good afternoon again, everyone, and welcome to today's webinar brought to you by 5GIANA. For those who are not familiar with the project, 5GIANA is an EU-funded project that provides an open 5G experimentation platform to enable the development, deployment, and testing of automotive-related 5G applications. Today, in today's webinar, we will be looking into the project's experimentation infrastructure that we will be utilizing in the framework of the project with third-party experimenters and small medium enterprises. And this infrastructure comprises of 2 5G testbeds, one in Germany and one in Slovenia, autonomous vehicles, one real and virtual, and the different OBUs and RSUs that we will be using. I hope you can all hear me. My name is Stevi Christoforou, and I am a Communications and Dissemination Officer with ICCS, which is the Institute of Communication and Computer Systems in Athens. ICCS is also the coordinator of 5GIANA, and I am the dissemination task leader of the project. I will be moderating the webinar for today. So before we get started, I just wanted to inform you that you will have the opportunity throughout the session to submit your questions to the Q&A box, the option that you can find on your control panel, and that we will be taking all the questions towards the end of the webinar, where we'll be dedicating 10 to 15 minutes for the Q&A session. If you're experiencing any technical issues with audio or not seeing the presentations correctly, please let me know in the chat so I can have a look at it. And now for introducing the agenda of today, I would like to ask all speakers to turn on the webcams.
Yeah, hello.
Hi. I cannot see you, so please let me know. I will continue. Okay, I can see you now. Thank you, and a warm welcome to you all. Thank you for being with us today. Just a short introduction for each of you. Our first speaker for today is Ross Tatum. Ross has more than 20 years of experience in cellular radio technology, working in product development and test for UMTS 3G, LTE 4G, and NR 5G systems. He's currently working as a project manager in the mobile networks architecture and specification group within Nokia. And today he will be describing Nokia's testbed that is also part of the 5GIANA project, which is located in Ulm, Germany. Welcome, Ross.
Thank you.
Next, we have with us today Dejan Solster. He's the head of research and development in Telecom Slovenia. He is involved in many projects within Telecom Slovenia with a focus area on 5G, especially in the field of private non-public networks, PPDR, utilities, and Industry 4.0. Dejan will be taking us through the second 5G testbed of VIANA, which is located in Ljubljana, Slovenia. Welcome, Dejan. We also have with us today Jose Isola. Jose is an automotive engineering Master of Science graduate from Politecnico di Torino with a passion for automotive technology and robotics. He specializes in autonomous driving and currently works in the AI, AD, HMI division at Biologic, as a software developer, where he supports in the creation of state-of-the-art solutions for the various challenges faced by the automotive driving industry. Jose will be introducing us to the project's real and virtual vehicles of 5GIANA and the overall playground of the project. Hello, Jose. And last but certainly not least, we have with us today Eduardo Bonetto. He's a researcher at the Links Foundation. Eduardo is a telecommunication engineer with more than 10 years of research experience in the telecommunication networks field. Currently, he focuses on the evolution of mobile networks and their applications to different vertical sectors, such as CCAM, Cooperative Connected and Automated Mobility. And in particular, he's working on the architecture, design, and implementation of V2X communication solutions and safety applications for connected vehicles. Today, he will be taking us through the flexible OBUs and RSUs of the 5GIANA project. Thank you all for being here today, and I wouldn't want to take any more of your time. So, Ross, the floor is all yours. And that rhymes.
You can see it okay, Sevi? Thanks, Sevi, for the introduction. Good afternoon, everybody. So I want to give you a quick introduction into the 5GIANA testbed, which has been established by Nokia in the city of Ulm in Germany. As you know, Nokia is an international company with many offices around the world. And for the mobile networks division, the R&D centers are based in Europe, USA, and China, also India. And in Europe, one of the big R&D centers is in Germany and actually here in Ulm. So 96% of the people working at Ulm are working on mobile networks products. So we have over 700 employees here. And apart from product design and development, we also have some European projects which are sponsored by the European Commission, such as 5GIANA. So that's why we're here. And if we go to the next slide, I'll give you an overview of what we're doing. So maybe it looks complicated, but this is the 5GIANA setup. And you can see the blue boxes are computing platforms or server hardware. The horizontal dashed line in the middle is separating them by location. So you can see the servers on the top of the screen, they are not within Nokia. Actually, they're not even within Germany. They're elsewhere. These are operated by our partners within the project. And these partner companies can connect to the Nokia servers in the bottom part of the screen via a VPN tunnel. Okay, what's not shown is also beyond the partner companies at the top, there are possibilities to have further small, medium-sized enterprises, smaller companies who are working together with the IANA partners, and they also can get access via the partner companies to these VPN tunnels and therefore can access the 5GIANA test network. Okay, then the servers running inside Nokia, they are providing the platform servers for the 5GIANA platform. So the different toolkits and orchestration units here, and also the edge server is here for the low latency data processing. The red arrows show the administration, so loggings and configuration options for the partners, but there's also the data flow, and the data flow flows mostly between the roadside units and onboard units across the mobile network to the platforms, to the edge server, and the edge server can also share data with the platform server and so on. So we have a low latency setup here. All these servers are located within Nokia laboratory. I'll show that in a later slide. And they are connected over our 5G mobile network to the onboard units and roadside units in the field. Of course, the 5G mobile network here is shown as transparent. It's not important to the applications or the users, but for us, of course, it is important, and it's one of the key parts of our setup here. So the next slide will show more about the mobile network itself. And later on, Eduardo will explain more about the OBUs and RSUs. So that's the general setup. If I go to the next slide, yes. So you can see that inside the 5G networks, we have a 5GIANA testbed that is part of the 5G standalone network, which we operate here in Ulm. And devices or OBUs or RSUs can use Nokia SIM cards to access this test network. So in this example, we have the OBU in the vehicle. It's connected to one antenna site of our test network. We have 4 main sites, and these antenna sites are then connected by optical fiber to the 5G G-Node B, which is located within our Nokia building in the laboratory, together with the platform servers and the edge servers. We also have the cloud, the core UPF, so the user plane function located here, so that the data flow is routed quickly, low latency, to the edge server. Then from the edge server, we can go to the platform server, as shown in the previous slide, for processing, edge processing, or we can forward the data across the VPN tunnel back to the partner company. We also set up 2 slices here, 2 network slices, to enable prioritization and to improve the performance for certain data links or services. So a device or an OBU can connect to 1 slice or 2 slices, depending on what services they're being used. And we can separate the slices via the DNNs, so the nodes we're accessing. So one example might be the vehicle is sending a video via the enhanced mobile broadband slice. At the same time, it is receiving V2X commands via the V2X slice across the 5G network. Okay, then, yeah, and with the slices, we want to show the prioritization and to ensure that the V2X commands have the higher priority compared to the mobile broadband. Where these locations for the 5GIANA testing, we're using the site that was shown in the picture below on the previous slide. And we have this area which is next to the University of Ulm, and we have 2 sectors, and we can operate devices within these 2 sectors. At the moment we are focusing on the parking areas here, but there are also, you see on the next slide, there are also paths that we can use. We're using the TDD frequency band around 2.6 gigahertz, which is band 38 or band 41 in the spectrum. We have to use this band so that we do not interfere with the commercial 5G operators who are also, of course, operating 5G in this area. If we talk about cell throughput here, you can see the parking area that I was talking about and the paths around the parking area. We have a mostly rural area. We also have a suburban area, and the throughput rates, they vary, but around between 100 and 200 megabits per second in downlink. And this is sufficient for our 5GIANA tests. For uplink, it's between 10 milliseconds and 20. Usually, versus uplink throughput. Uplink throughput is between 10 and 20 megabits. Mostly here we have 20 megabits or more than 20 megabits per second uplink. Here, between 10 and 20. And as you go further away, it will change, but the uplink throughput varies a lot. This is normal when you're driving around here, but it should be sufficient for video and what we want to do here. And the latency is also pretty good because of its all low latency setup. We have about 10 millisecond round trip time latency here, and device to device at 20 milliseconds. So we're looking forward to testing with this with 5GIANA. We already started, actually. This is a photo from this week. With this device here, we were testing the 5G network and remote driving, and it was working fine. So we're looking forward to doing more tests with you in this year and next year. So plan is to operate these tests in June, July this year, and then later on in the year next year as well, depending on the schedule. So anyway, we're looking forward to doing more 5GIANA tests with you, and I hope you got a good understanding of what we're doing here. And if there are any questions, then we can talk about that later. Thank you very much. Back to you, Sebi.
Thank you so much, Ross. We have a question, but we will take it at the end. All right, let's turn to Dejan now. Thank you again, Ross. Dejan?
Thank you. Just a second, just to share my screen. Hope do everyone see my presentation and to hear me clearly. Thank you, Sevi, for the nice introduction. Today I will talk about 5G testbed, the second one of the 5GIANA project that is located in a small country of Slovenia. So we built the second testbed around our use case named situational awareness in cross-border road tunnel accidents. It's an indoor testbed with dedicated infrastructure located at our premises here in Ljubljana in our research lab at Telekom Slovenia. As you may know, we are the largest telecom operator, MNO in Slovenia. We are a lot involved in research projects, 5G, 6G, like 5G project like this 5GIANA. So we are glad to be part of such a nice project. Our infrastructure consists of cloud and virtualization environment needed for the demonstration purposes of our use case, edge capabilities, network connectivity for sure, with 5G standalone core, and also with the 5G Uni radio, especially with the radio with the band N78 with 3.5 GHz. Optional, we also have some additional LTE capabilities, narrowband RT, LTM, and so on. So about the cloud and virtualization infrastructure, this is the main compute, storage, and network power for our use case. It serves as a container for deployment of VNFs, also for the MANO with the Kubernetes. And in the first place, we didn't plan to host 5GIANA NetApp toolkit, but with the project progress and at this point, we all think that it could be good also to host NetApp toolkit in our testbeds, as it is more likely that we will also host additional use cases. This Nokia testbed and Telekom Slovenia testbed, they should be more or less the same, but our testbed is indoor only for now, because our use case is it's an indoor use case because it is only for demonstrative purposes of the demonstration of the tunnel accident. So we can use really the tunnel to demonstrate the accident. So we use our lab facilities in our lab. This is the high level architecture of our testbed. It's built with another Slovenian partner of this project, Internet Institute. As you can see, the layers for deployment, verification, and testing of our use case. We will be using a two-phase approach, and in first step, we will use with the mobile edge computing centric VNFs that will be deployed and verified in Slovenia in our testbed. We'll be focusing on automated MANO-based VNF deployment, real-time streaming capabilities, and also deployed business logic of monitoring VNFs in that single, let's say, single operator 5G environment. But in the second phase, all that use case capabilities and elements, including in-vehicle placed OBUs, RSU units with all attached sensors. This will also be tested in and verified in federal 5G environment. So just to show that inter-domain aspects of 5GIANA ecosystem. On one side, the Nokia testbed in city of Ulm will be interconnected with the testbed here in Slovenia, in Ljubljana. So the multi-domain NetApp orchestration and development framework capabilities on that bound could be exploited to enable automotive-related VNFs deployment and its lifecycle management. So in that manner, we will get multi-operator 5G infrastructure and to show cross-border operational aspects. This is another scheme of the physical level architecture in our facilities. We have cloud infrastructure on the right side, network elements in the middle, and devices on the left side. So, as I said, all these two test beds will be interconnected. So the 5GIANA automotive open experimentation platform is designed to be operator and domain agnostic. Specifically, just to show this cross-domain and cross-platform interoperability of our use case. And with that, we will emulate a cross-border scenario where the Nokia testbed on one side, let's say the border, and Slovenia testbed on the other side border will be interconnected. As I mentioned earlier, as project progress, we may host additional use cases in our testbed also, not just the one with situational awareness. Virtual bus tour is also a potential candidate to be tested and validated also in our testbed, and maybe network status monitoring also. So we are, for that purposes, we need additional location, because these two use cases are outdoor use cases, and that's why we were trying to find additional, or let's say good enough location for demonstrated purposes and also for the validation. So in our second location, it's a good. We think it's a good outdoor potential testbed location. It's our second building with these parking lots that are in red circles. Where we also have some outdoor radio head units that could be connected to our 5G test core with standalone test core in our lab. Unfortunately, at that point, our let's say experimental 5G standalone network is not supporting slices yet. We are building this 5G core with our outsourced partner, and hopefully we will get that functionalities when this testing and validation phase will be as planned. So basically, that's it for our site for my testbed. For any additional questions, I will be available at the end of this workshop. Thank you.
Thank you so much, Jan, for your presentation. And now we come to our next speaker, Jose.
Hello, here I am.
Hi, Jose.
So I'm gonna put the presentation. Let's see. Okay, so, well, as Sevi already introduced me, I'm Jose Isola from Biologics, and I will give an overview regarding the part that we are handling, one of the parts that we're handling in this project, which is the things of Carla and the autonomous vehicle Vega. First, we will talk about two main components regarding the passenger vehicles available, the actual real-life vehicle Vega, the virtual twin, and then how they all come together in the 5GIANA playground. First of all, we have Vega, which stands for Vehicle with Autonomous Driving Vehicle. It is a CE level 4 autonomous vehicle based on the Citroën Imeari, as you can see in the image here. And as for sensing, it has the main sensor setup that you can see in an autonomous vehicle, or that you will eventually see in autonomous vehicles: LiDAR, stereo vision, thanks to an array of video cameras, GNSS receiver, and an IMU. The actuation systems are drive-by-wire, steer-by-wire, and brake-by-wire. So basically, by means of electronic commands, you can drive the entire vehicle. There's also the possibility to drive the vehicle manually, as the main controls have not been removed from the vehicle. How does it connect to the platform? So in this case, for the 5GIANA project, Vega will also be, of course, fully connected, thanks to the Links onboard unit, which will be explained by Eduardo on the following presentation. And there's the possibility to exchange information to and from the vehicle. So there's the vehicle systems will have an understanding of the world thanks to the sensing, for example, occupancy grids or other sensor information, position information, which will be communicated to the platform and eventually to the NetApps or NApps that will be running on top of it. So that's the part that third parties you will be developing. On the other hand, from the NApps, there can be you can send messages towards the vehicle, so the vehicle can actually be commandeered from the platform side. Furthermore, there's the possibility to send messages to the HMI systems, as can be seen in the bottom images, on the strategy views and the ego motion views on the left-hand image. And in the strategy views, there's the possibility to send layered maps. So as it can be seen in the right-hand side, there's the possibility to send a layer of the map. For example, in this case, there's the road network definition. And then there's the possibility to place icons, which are statically placed in the map, like that small icon regarding the speed limit, or a rover, which is a sort of movable icon on the map. Furthermore, there's the possibility to publish messages into the screens, also in the EcoMotion screen, to alert the user of this autonomous vehicle of any situation that you might want to let the user know about, of course. Then we have on the other side the virtual twin. It will be running on Carla, which is an autonomous driving simulator. It's pretty well known. If some of you have already worked in autonomous driving, probably you've heard about it. It's an open source project based on Unreal Engine, so it runs on a video game engine. It's pretty well supported, and it's pretty scalable and easy to build on, thanks to its open source nature. So we decided to run with this project in order to create a digital twin to expand on what will already be available in the test bed, which also includes, of course, the physical vehicle. In fact, we started by adding a virtual version of Vega to have a standardized autonomous vehicle to place in the simulator. It will have the same vehicular infrastructure as Vega. In fact, we're also trying to put a physical model of it. Here you can see a work in progress model that we are trying to get up and running with the photogrammetry. Nevertheless, the sensing systems have already been placed in a dummy model in in Carla, and it runs, and it's gonna have the same interface as the real vehicle thanks to a specifically developed Carla 5GIANA plugin and the combination with what is called the virtual OBU. So this is, of course, you already have the vehicle, but we also need the virtual world to run it on. So the idea would be to create a digital twin of the test bed, specifically the Nokia parking lot, and to define a road network inside this parking lot using OpenDrive, and having, of course, a physical temporary definition of a road network of that place, so as to create a digital twin of that specific place, which also have georeferencing information. So what is seen in the simulator is pretty much one-to-one with what would be seen in real life. In fact, here in the bottom right, you can see that we already created a test map of the biologics offices, which are not located at the test bed, but it was faster for us to develop an initial version where we have the same infrastructure as the building, the same orientations, and the same GPS coordinates. Then regarding a little bit more of a technical aspect, as to say, the plugin will be running on top of the client API of Carla. So there's going to be a server instance running a Carla server that is going to be running the world itself, and then a client that will connect to it. And using the 5G plugin, it will transmit and receive information to and from the virtual vehicles to the corresponding virtual OBUs that are there on top. And then on top of that, there's the 5GIANA platform. On top of that, of course, your NAPs that we expect to see. How does this all come together in general? Well, at this point, the whole thing comes together by having these two maps that are, well, the real world location and the virtual map. And for the end user perspective, or from the developer perspective, from the NetApp perspective, they are one and the same. You have the real vehicle running on the real road, which is using its OBU to send information to the platform. And at the same time, you have virtual vehicles that are sharing the same road, but in the simulator instance. The good thing about this is that it doesn't matter what kind of test you want to do. If you want to do a test with the real vehicle, or if you want to do a test with the virtual vehicle, the interfacing that you're going to have with the system is exactly the same. So you can start, for example, by creating an instance of a single car in the simulator. You can request to create instances of vehicles in the simulator just to test initial connections, initial controls, and then you can move to a single instance of the real vehicle that we will have available at the test bed. And then at the end, you can scale up the whole thing and put a lot of traffic into your test bed, and they will all be running simultaneously, both the real traffic and the virtual vehicle, and they are going to understand each other as if they were there. So basically, it's a whole playground. It's really flexible for you developers to do as much as you can, or as much as you want. Thank you for your attention. Well, you already know the deal. If you have any questions at the end, I'll be happy to try and clear your doubts. Thank you again, and back to you, Sevi.
Thank you so much, Jose. I'll see you in a few minutes again. And now for the last presentation on the OBUs and RSUs. Eduardo?
Hello everyone, I'm going to share my presentation. Okay, so today I will shortly provide some insight about the OBU and ROSA unit that as links will be made available for the 5GIANA project. So this far edge device that we developing links are a proof of concept and they are derived by commercial off-the-shelf hardware that we integrate in links. And apart from the hardware, we also provide some modules, software modules that provide the CITS commission stack for easing the development of application to third parties. So this device has been conceived for testing and experimenting different CCAM use cases, and we made also available some open interface to use some of the modules that we already developed. Both OBU and ROSA unit are embedded device and they are based on a board with integrate an NVIDIA Jetson 7X. So it's based on ARM64 architecture, and this can ensure sensor performance since it can provide both graphical processing unit and a high-end CPU with several memory available. So focusing on the onboard unit, we provide the OBU with a 5G tailored modem, and to enable the 5G connectivity, we test this modem already with 5G network both in non-standalone and standalone mode. And together with the 5G connectivity, we can also ensure high accuracy because in the OBU integrate RTK receiver from the U-blocks. In the case that experimenter want to add the external sensor, we also made available one Ethernet interface that can be used to connect to some sensor or to the vehicle network using a high-speed connection. Furthermore, the LinksView integrate a Wi-Fi interface and is able to create a Wi-Fi hotspot for enabling the interaction with the smartphone or maybe with other wireless sensor. The ROSA unit is being developed for collecting information from roadside sensor. So as the OBU, it provides 5G connectivity for broadband and low latency connection to the edge server of Nokia. And the RCU that we provide is also available with a camera and a solid state LiDAR. This can be used for developing application related to road safety or maneuvering coordination. In any case, any CCAM use case that can need to have perception of the road segment. Also, in this case, there are available some interfaces, Ethernet, USB for adding some sensor, and also here we can make available a Wi-Fi hotspot. So these are the two items that can be used for experimenting application on the CCAM field. But for Linux, we made also available some software modules. So I group the network function, application function that we made available in two main sets. The first set is concerning all the modules that are related to the communication of CITS messages. Basically, they can be used for implementing a complete end-to-end ITS communication according to the ETSI standard. So this module can enable the network communication using 5G UU interface. Then we provide also the different module that can be used for creating status messages such as CAM, DNM, and the other most used ETSI messages. While we provide also some utility, some facility module that can provide position and time information, or it can provide some relevance about the event that they are in the surrounding of the OBU. Other set of function concern instead the processing of the sensor data. So we can make available some application function that can perform object detection and multi-object tracking. So all these modules can be considered as a starting point for building CCAM application so that the third-party implementer does not need to focus on how to exchange messages or how to process sensor data, but it can focus on developing the core application that is in this business field, while relying on our modules for all the lower stack aspect. So just last example to show how this module can be used. Here we have on the left side the Edge server, on the right side the view. You can see that all the Webbox module are provided by us. For instance, on the Edge server, there could be a camera data flow, for instance, a RTSP stream. Our modules can perform object detection tracking and provide information to an external application function module. For instance, in this case, I show a queue warning event detection application, and then this third party's application can exploit the information from sensor to identify a dangerous queue situation and communicate to OBU this information using ITS communication. So we provide all the modules that create the relevant messages, the communication, and also provide the information about the event on the OBU side. So the third-party experimenter does not need to develop this aspect, but just concentrate on the queue warning application on the Edge server, and in the case that the vehicle is equipped with an ADAS module or an HMI, develop the interface towards the module that may be specific from vehicle to vehicle. So this concludes the introduction about OBU and ECU and related software. If you have any question, I'm available for providing you answer.
Thank you so much, Eduardo.
Welcome.
We are closing the presentation just in time, so thank you so much for being super efficient with time. Let me ask the presenters one more time to turn on their cameras so we can open the floor for the discussion. I'm afraid I have a problem reaching the Q&A application, so in case you have inserted any questions to that box, I would like to ask you to copy paste it to the chat so I can also I can see them. All right, let me start with one of the last questions from Luke Yaman. I think this is directed to you, Eduardo. By position, you meant the position of the vehicle in one of your last slides?
If you refer to the position and time function, yes. On the number unit, the position time modules can provide information about the real-time position of the vehicle to application running on the OBU.
All right, thank you. Look, also say thanks. A question from George Arapiu. The CITS messages, how are they communicated to the Nokia testbed? Ross?
Well, I think it's what Eduardo was explaining in his slide.
Yes, I think that
Sorry.
I can answer both to Marcelo and to George's question. So
Okay.
in 5GIANA, we support vehicle to network communication. So the focus is on the 5G communication using the UU interface. So all the SATI messages are exchanged passing through the network, and our approach is the one introduced in the 5G Carmen project and also in the C-Road platform. So the communication rely on a message broker, namely a NameQP 1.0 broker that is installed on the Edge server. So different OBU ROSA unit, they need to exchange SATI messages, send the messages to the message broker on the Edge server using the U interface, and then the OBU RSU that want to receive messages can subscribe to specific topic on the message broker to receive these messages. So our OBU also support V2V such as ITSG5, C2X communication, but in the 5GIANA project, we focus just on V2N using 5GU interface.
Another question from George. The Edge is Nokia system?
Yeah, that's correct. The Edge is a server. It's actually an airframe, Nokia airframe server. So its hardware is also from Nokia. It's located within the Nokia laboratory on the basement of our building. And it's connected to the user plane function, which is part of the core, which is then connected to the GNOB. And so we have very low latency.
Right.
Sebi, there was another question earlier from Paolo. Maybe
Yes.
Jose can help. I want to know about this controlling the path of the vehicles.
Yes, I think that was directed to Dion, but also feel free to jump in. For the outdoor and indoor locations, do you have any facility to remotely control the path of the vehicles, the robots, etc.?
So maybe I can get to that one.
Yes, of course.
At least for the outdoor location, short answer is yes. We are also developing as part of one of the use cases a maneuver coordinator NetApp, which should be doing exactly that. It should be coordinating maneuvering of different vehicles that approach an intersection, and for that it will have to create pathing paths for the vehicles involved. At that point, the coordinator messages will also transmit probably pathing data to the vehicles. So short answer is completely big yes for the outdoor location. For the indoor location, I don't know if I don't think we're supporting autonomous driving functionalities or functionalities of this type. And that's pretty much the answer. This is also valid for the virtual vehicles running on the digital twin of the Ulm test bed, of course, that you may be able to also see them using the simulator instance.
Thank you, Dion. I don't know if someone wants to add something.
At that point, nothing from my side.
I meant Jose. I'm really sorry.
Okay.
There was another question from your Rabil. I'm not sure where this is linked to, but is slicing dynamic or static, meaning pre-allocated?
Yeah, that would be to me.
Thank you so much.
Okay, George, I'm not sure what you mean, but I guess the slices are not fixed in terms of resourcing. So what happens is you configure a target ratio. So say you have 100 radio resources. Let's say you divide the radio resources of a cell by 100. So you have percentage-wise, you can assign 30% to one slice and 70% to the other slice. But if nobody is using those resources, then they are free for the other slice to use. So if there are no devices using the V2X slice, then it means that the other slice has 100% of the resources available. But if there are devices using the V2X slice, then they have priority. So those 30% of the resources, that's the V2X, those will be reserved for the V2X devices. So the other slice, the EMBB slice, will only have 70% of the available radio resources. But it's dynamic in the sense that if nobody's using them, then they are free for everybody. But we can't change that ratio on the fly. The ratio is configured by us. Hope that helps.
Thank you, Ross. Another question coming from Marco. He apologized if he missed that point, but are the 2 test beds meant for being used by external parties for experimentation? And if yes, how is that being accomplished? Example given to place third-party NetApps to the edges and complementing CCAM applications to the OBU, etc. Who would like to? That's a rather wide question, but who would like to take it?
Maybe for the answer. One part of the project was also open call, where the third parties can participate with their NetApps. As I'm aware, both testbeds will be open for external parties to get to the experimental platform. That's why also we are planning to get additional platform server to host the NetApp toolkit. So that's why this is one part of why a NetApp toolkit should be also hosted by our testbed. What are plans for Nokia, but I'm not aware of, so maybe Ross.
Sorry for the testbed. I didn't get the question. Dejan, can you repeat?
Do you have any time plan for the third parties to get to your experimental testbed?
Time plan. I mean, okay, it depends what you want to do. So yes, we have to arrange certain days for vehicle testing. We can't just have anyone turn up on any day and drive a vehicle. It won't work. But some devices are always available. The network is available 24/7 every day. But the question is what devices are in the network. That's the point. So the platform server and the edge server is always available. We don't switch it off. But which devices are actually in the network on that day depends on what we've planned and who's available on site. So some roadside units, maybe from Eduardo, will be permanently available, but we have to work on that to see what's going to be available when.
Yes, I confirm that the OBU and the ROSA unit that I presented before will be available also to third parties experimenter, and also the software module that I presented can be used within the context of 5GIANA for creating CCAM application. And if any third-party experimenter want to test some of their NetApp on the OBU, also this will be possible by using the 5GIANA platform. So yes, I think that the answer is yes.
I'm also adding Irini Lotu to our conversation for this. This is the deputy coordinator of the 5GIANA project. So Irini, if you'd like to.
Hi, also from my side.
Hi, Irini.
Hi, so thank you for the interesting questions. We are very excited to see that there is interest and you want to know more details. Regarding the last question of Marco, I would like to point out that there is an open call currently receiving applications for experimenting on the 5GIANA platform. So if you are interested, you can drop an email to the email that you can find in our website, in the link that I have shared in the chat, or you can contact any of us that you see here today. And we would be very happy to discuss with you and see how we could help you. You don't need to have all the answers now ready regarding exactly how you could plan to do the validation and the testing on the test beds, but rather we would like to discuss together and see how we could help you really create a service on our platform and what would be the added value to this. So if you are interested, the deadline is for next week. However, we can extend it. So if there is an interest, we can extend it. The application is very simple. You just need to give us some information online. For example, your experience with 5G, if any, your experience with other research projects, if any, what would be the scope of the scenario, also what is the general scope of your organization. And then we will evaluate your application basically in terms of eligibility and feasibility. And we will start a cycle of discussions to see how we can help you. So please visit our website.
Thank you so much, Irini. And Marco mentions that he will be checking the open call description. Yes, and if you need any additional information, it's all like all the information is very well presented in our website. But again, as Irini mentioned, feel free to send us an email in case you have any questions or require additional information. Let me just go back to another question that I've noted in the beginning, and that is addressed to Dejan. That's why I also had your name in my mind. Could you perhaps explain what was the biggest challenge in setting up the testbed in Slovenia, in Telekom Slovenia?
The biggest challenge. I think that the biggest challenge was regarding the market conditions, if we will get on time all the needed hardware, so servers and antennas, basically some additional 5G indoor stairs and outdoor stairs. We're still waiting to expand our testbed. Then as we have our experimental 5G standalone core outsourced, the slicing maybe it's now the biggest challenge, because we would like to have fully operational testbed with all let's say 5G features available to host maybe some other additional use cases. That's why the slicing is much needed or wanted. This, I think, it's the biggest challenge in our testbed.
Thank you, Dejan, for your answer. All right, let me share my screen one more time. So I think we have come to the end of our plan agenda. Instead of taking more additional questions, you can always send an email to info@5GIANA.eu or reach us through our social media networks. Before we conclude the webinar, I would just like to ask the presenters and Irini, you as well, in case there is anything else you would like to touch upon before we wrap up.
Now we look forward to doing some fun experiments with this setup, either here or elsewhere in Europe.
Perfect.
Exactly. I was going to mention that.
Right, great. Then looking forward to that, as was mentioned. Thanks a lot to everyone who joined. Many thanks to the great speakers for your presentations and your input today, and of course the audience for being part of the webinar. Again, don't forget about the open call. The deadline for submissions is next week with the possibility of extension, but we're here for any questions and to support you in throughout the application procedure. And yes, again, thank you so much for joining. Stay in touch, follow us on our social media, and looking forward to some great testing and to speak to you again. Good afternoon to the speakers. Have a good afternoon, and yeah, thank you, everyone.
Thanks.
Thank
Bye.
you.
Thank you.
Have a nice
Bye.
day. Bye-bye.
Thank you. Bye-bye.